All right then. This is the second video, and we're gonna jump right into adding and subtracting of fractions. Now, adding and subtracting of fractions has its own very specific set of rules. But the most important thing to remember here is the denominator. All right, the denominator is where a lot of a lot of my students get confused. All right, and they make mistakes because they seem to make sense, but that is not the case. All right, so first off, let's start by looking at what is happening when we're adding fractions. So what's happening when I'm adding, for example, we just have that as example one, when I'm adding a half plus, let's say, 3 halves. All right, what is essentially happening here is I'm adding half a pizza, right, plus a full pizza, and another half there, right? Because 3 halves means I have 1, 2, 3 halves. That's what's happening here. And that is why it's important for us to never ever do this. Never, when adding or subtracting fractions, never do this. 1 over 2 plus 3 over 2. Never say that is equals to 4 over 4. You do not add your denominators, because you need to remember we're dealing with fractions of halves here. Essentially, if you did this, it would mean we're now dealing with pizzas that are like that. And that's completely changing what's happening with this fraction. We're adding halves. And so what is correct to do is, let me just separate that there. So what is correct to do is you always check for your denominators. Your denominators must always be the same in order for you to do the addition or the subtraction of the fraction. Here our denominators are the same, they're both 2. So we're then going to say 1 plus 3 divided by our common denominator, which is 2, and that gives us 4 over 2. And if we think back to our simplification of fractions, 4 divided by 2 is equal to 2. All right, so that is the first glimpse at what's needed and the most simple situations of adding and subtracting fractions. So if it's always made easy for you, if the fractions that you have to add or subtract all look they all look all already have the same denominator. So let's look at an example where we're subtracting. Let's call that example 2. We have 3 over 5 minus 2 over 5. Rather, let me use a bigger one there. Let's say 6 over 5. All right, so what's happening here? We look for our denominators. Our denominators are the same. So what we do is we're going to say 3 minus 6 over 5. And that's going to give us a negative answer where we have -3, right? -3 over 5. So if this were on a number line, if that's 0, our fraction would be this side. We would have a -3 over 5. Okay, all right. Once you've got that down, we start looking at the more complicated ones. All right, what if I then gave you a fraction where the bases are not the same? Let me look for a really nice one here. Say example 3, where the denominators are not the same. Let's go with 2 over 5 plus let's go with 7 over 4. Our denominators are not the same, and it's at this point where we introduce a very important concept called the lowest common denominator. And what this is essentially you have to look at your denominators. Our denominators are 5 and 4. And you ask yourself, what is the lowest possible number that can be divided by 5 and be divided by 4? Okay, if we think about it, let's think about the multiples of 5. The multiples of 5 are 5, 10, 15, 20, right? And let's go up to 25. And now let's think about, can 5 can divide into all of these, right? This is once, twice, third, 4 times, 5 times. Can 4 divide into 5 perfectly or nicely? No. So this is a no. Can 4 divide into 10 perfectly? No. Can 4 divide into 15 perfectly? That's a no. Can 4 divide into 20 perfectly? Yes. And this is the lowest common denominator. The lowest possible number that both 4 and 5 can divide into. So if we continue our sum now, right, we're trying to add 2 over 5 plus, I think it's 7 over 4, right? Just check myself. Yes. Okay. We've established that our LCD, our lowest common denominator, is 20. So once you've established your LCD, you're going to ask yourself, how can I change 5 to make it equal 20? Well, that's pretty straightforward. That's pretty easy. You're going to say 5 times 4, right? Because 5 times 4, if you put that in your calculator, you shouldn't need to, guys. Come on, times tables. But if you put that in your calculator, right, it will give you 20. 5 times 4 is 20. And so what I do at the bottom to my denominator, I also have to do to my numerator. So what that's going to give me is, right, let me not put that in red. What that's going to give me is 5 times 4 is 20, and 2 times 4 is 8. And the same applies for this side. I look at my denominator 4 and I ask myself, how can I multiply 4 in order to make it equal to 20? And that's easy enough. 4 times 5 is equal to 20. And what I do to my denominator at the bottom, I have to do at the top to my numerator. So 7 times 5 as well. And what that gives me is plus, so we have 4 times 5, which is 20 there, and 7 times 5, which is 35. All right. So now, if you look here, you should notice that we have the ideal situation we were talking about earlier. Both our denominators are the same. So once we have both of our denominators the same, it's very easy from here. We're just going to say 8 plus 35 divided by 20. And what that gives us is, what, 43 over 20. And I don't think we can really simplify this any further, but therein is our answer. The same applies for subtraction. All right, if I say we're subtracting the following, let's see here. We are subtracting, so this would be example 4 if I'm not mistaken. We are subtracting, let's see some really nice ones here. Let's say we're subtracting 3 over 4, all right, minus 5 over 8. Okay, what our denominators are different. All right, so immediately you need to start thinking about your LCD. You ask yourself, what number can both 8 and 4 divide into? So let's look at the factors of 8. Factors of 8 are 8. So 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. Let's go that far, right? Then we think about it. Does 4 divide into 8? Yeah. All right. Does 8 divide into 8? Yeah, 8 divides into 8 one time, and 4 divides into 8 two times. So what we're doing here now is we're gonna say, okay, so our LCD is 8. This is the lowest possible number that both 8 and 4 divide into. Never forget that a number can divide into itself always one time. So our LCD is 8. So what we're then going to do is we're going to say that's equals to. So then I ask myself, if we have 3 over 4 minus 5 over very ugly 8, 5 over 8, right? You ask yourself, what can I do to 4, right? What can I do to 4? How can I multiply 4 to make it 8? 4 times 2 is 8. So what I do at the bottom, I do at the top. What can I do to 8 to make it 8? Nothing. I don't really do anything there. If you want to be technical, you can say 8 times 1 and 5 times 1. But this is not going to change because 8 times 1 is 8. 5 times 1 is 1. Is 5. So our conversion, our changes here is we're going to have 3 times 2, which is 6, over 4 times 2, which is 8, minus 5 over 8. And if you notice here, our denominators are the same. So we have a very simple sum here. We have 6 minus 5 over 8. And that is 1 over 8. And there is our final answer. Okay. So they will try to confuse you guys and trick you by giving you even more complicated ones. They'll give you sums where you have something in order. Like let's go with 4 over 5. Well, not in order, but a lot of things to add and subtract. So we have 4 over 5 plus 7 over 9, all right, minus, so we have a plus and a minus in the same sum. Let's go with 8 over 9, all right? So don't be confused here. What you need to just stay calm and realize that I've got a plus sign here and a negative sign. I've got fractions, so I'm just adding and subtracting fractions here. So immediately I look at my denominators. Not all my denominators are the same. Okay, so what I would then do is I will then go and say, what is my LCD? All right, look at what's my LCD. I have 5 and 9. What value is there that both 5 and 9 divide into? The lowest possible one, I can definitely tell you that it is 45. All right, 45 divided by 5 is 9, and 45 divided by 9 is 5. So when we have our LCD, just like we've been doing now, you ask yourself, how do I change 5 to make it 45? Multiply by 9. How do I change, so what I do at the bottom, I do at the top. And these ones, I'm going to multiply by 5 respectively. My 5s look like S's, but yeah. Anyway, okay, so what do we have here? What's 4 times 9? 4 times 9 is 36. 36 divided by 45, which is 5 times 9. We have plus 7 times 5 is 35 over 45, minus 8 times 5, which is 40 over 45, which is 9 times 5. And once we get here, just as usual, we should be happy because now we have all our denominators is the same. So what we're going to have is in a 36 plus 35 minus 40. And that's all over 45. So from here, simple adding and subtracting. I think 36 plus 35 is 71. Minus 40 should give us 31. 31 over 45. And there is our final answer. All right. So guys, let's not be daunted by sums like this. Let's not forget what we're doing here. But it's also important to know what we're not allowed to do. So what I've seen a lot of the time is students who mix up the rules. So let's use this as e.g. 6. So these are the do nots. All right. Let's say we have 5 over 6 plus 25 over 12, right? Minus, let's go with, let's say 3 over 2, right? So what a lot of students would do is they'll mix up these rules with the rules for multiplying and dividing fractions, and they'll do something like this. They'll say, okay, I see that 25 is a multiple of 5, so I'm going to say 5 divides into 25 itself once, and it divides into 25 5 times. I see 6 is also a multiple, so 6 divides into itself once, so they cross simplifying. Then they'll say 2 times there, and then they'll say, yeah, so this is 1 over 1 plus 2 over 5 minus 2 over 3. This is very wrong, guys. And why is that? Because you can't apply these rules across these signs, because these are separate terms. 5 over 6 is a separate term from 12 over 25, which is a separate term from 2 over 3. When we are multiplying, we're going to get into this in detail in our next video. 5 over 6 times 12 over 25. This is all one term. And so you can simplify within a term, doing what we were doing there. That's 2, that's 1, that's 5. Sure, this is lovely. You can do this when it's one term. All right. So let's not make that mistake. Let's not make that mistake at all. All right. So a few last things when it comes to these fractions. Do not mix up, or this is a very important one, don't mix up a mixed fraction, right? So 6 and 1 over 2 with 6 times 1 over 2. 6 and 1 over 2 is equal to 6 plus 1 over 2. This is a mixed fraction. Okay. And 6 times 1 over 2, right, is a multiplication sum. You're going to have 6 over 1 times 1 over 2, which gives you 6 times 1 is 6 over 2. 1 times 2 is 2, and that gives you 3. These are two very different sums, and do not mix them up. All right. I see a lot of students mix them up because this is possible though, because 1 over 2 times x can be written as 1 over 2x, where x, so this is algebra, where x is where 1 over 2 is the coefficient of x, right? This is not equal to 1 over 2 plus x. This is equal to 1 over 2 times x, and that can be written as x over 2, because x times 1 is 1x essentially, but in algebra we don't write that one, so that's equal to x times 2. So just a quick one there, very important. Let's not mix that one up, guys. All right.